Hi, my name is Matej. I'm the co-founder and CTO at Kriptal. And today I'm going to talk about the library we developed, EtherSKT, and the plan to convert it to Kotlin Multiplatform. So, quick introduction of who we are. Kriptal is a crypto-focused trading and development company. We've been founded in 2019. And there are basically two main things that we do. The first one is trading. Trading we only do for ourselves. We do atomic swaps on chain, such as Ethereum, and do cross-chain trading, and also recently block building on Ethereum as well. And then we also do some development for external clients. This includes custom EVM rollups based on Optimism and Arbitrum tech stacks. We also made a couple open source contributions. One is our EtherSKT library, which we're going to talk about today. And the second is Aragon block builder. Both of these can be found on our GitHub, which I'll link at the end. And we also made block building analytics, which can be viewed at the URL posted here. So in this presentation, like I mentioned earlier, I'm going to talk about EtherSKT and the reasons for its development. I'm also going to show how it streamlines the Web3 app development. And I'm going to finish with talking about our plans and our roadmap for supporting Kotlin Multiplatform. So what exactly is EtherSKT? Well, it's a library for interacting with EVM chains such as Ethereum, Optimism, and so on. It's very performant and extensible. When developing it, we put a lot of emphasis on making a nice API that guides the developer. So just by following the API, you're going to have the correct usage. It's also safe. We've implemented a lot of domain-specific types, as we're going to see later. And for error management, we opted for more functional style, which is based on the result monad from Rust. And the library is also fully async. But instead of coroutines, we have chosen to remain with features, mainly because part of our app is still written in Java, and we wanted to avoid colored functions, so-called colored functions, where you can only call suspend functions from different suspend functions. And yeah. It's fully open source. So why make another Web3 library? Like I mentioned, our trading infrastructure is fully written in Java and Kotlin. We've been using some other libraries since the beginning, and we noticed a lot of issues with them. They had usually poor performance. They had a lot of unsafe code. For example, everything was modeled around strings, which is really error prone, as we're going to see later. The error handling was poor, leading to subtle bugs in production. And there were also a lot of bad design choices, which made developing with those libraries much harder than it should have been. And a lot of times there were missing features, which we had to develop by ourselves. So by developing EtherSKT, we actually benefited from hindsight by seeing what worked and what didn't work with existing libraries. And then we improved upon them with our own experience in writing high-performance software for our trading. So let's check how EtherSKT improves upon existing libraries. So let's first check the performance part. This is a benchmark of ABI decoding of some solidity types. We measured average time and number of bytes allocated per operation. On top you can see the Web3j, which is an existing Java library we've been using until now. And we can also see an example of benchmark where we called Rust code from Kotlin. And then we can see at the bottom the performance of Etherskt, which is written purely in Kotlin. We can see that it's 30 to 40 times more performant than existing Java solution. And since it also doesn't allocate that much garbage, the impact on garbage cleaner is minimal. So why exactly is performance important? In short, it allows you to make more shortcuts in your own application when you're developing before you hit bottlenecks, and you don't have to you don't need to worry with the library becoming a bottleneck for you. Now let's check how we improved upon the safety of existing libraries. Like I mentioned earlier in the beginning, there are not a lot of domain-specific types implemented for in Web3j library. This is an example of simulating a transaction using an RPC call. We can see that the above hash is a hex string, but it's actually modeled as a string, which is really problematic if you, for example, mix cases. The hashes won't match anymore. And also it's very difficult to enforce length because hash is supposed to be exactly 32 bytes long, but here you don't immediately get an error if you create a hash with fewer bytes. And also for the RPC call, we can see that there are actually two code paths for handling failure. One is you can get an exception, and the second is that the actual call can also revert. So it's a bit difficult to handle failures in a simple way. So the same code looks like this in Etherskt. We have a domain-specific type for hash, which means that internally decodes the hex string into byte array, and so it doesn't matter what case the hex is put in, and the length is also enforced at construction time, so you immediately get an exception if you made a typo. And also we can see that there is only a single code path for failure and single code path for success, which really simplifies error management. Now let's check a bit the abstractions. Here is an example of a batch RPC call in Web3j. We can see that once the batch is sent, the returned response is not typed at all. And to access the results, you need to cast everything, which is really error prone, and it can lead to bugs at runtime. So we solve this with a different way. Everything in Etherskt is strongly typed. Here we can see that even if we add even if we add another function or remove an existing function, we would still get the fully typed result for the new call. which makes the code much simpler to use, easier to maintain, and it leaves less room for errors. Also, one thing regarding abstractions, the really important part with Web3 libraries is how you can interact with smart contracts. Usually, this is the most bugged part of the libraries we've used. So we put a lot of effort here to really make it as easy as possible to use. So what we've done is we have a Gradle plugin which takes the JSON ABI, which you get after you compile the Solidity code, which contains the interface information for this function. And the Gradle plugin automatically creates Kotlin wrapper code for all of the smart contracts. So you don't need to manually encode and decode the data. And basically, we supported everything from functions to constructors to deployment to events and so on. So this is an example of function on Uniswap, for those of you that are more familiar with this, for swapping on-chain. And this is how you can call this function from the library. Basically, it's a simple Kotlin function which takes care of decoding and encoding all of the Solidity types, so you don't have to worry about it. And then you can use the builder pattern to add additional parameters to the transaction, and you can either send it, simulate it, trace it, whatever. The code is very, very similar. One thing that I personally really like with the approach we took here is that all events and errors in smart contracts are modeled as sealed classes now, which allows you to have more comprehensive error management, because you can have comprehensive when statements, and the compiler is gonna generate all of the cases for you. So it makes sure you don't miss any error case or any event. So we also realized that it's impossible to include all of the features and cover all use cases in a single library. So we put a lot of emphasis also on the extensibility of the code. Here we can see an example of so-called middlewares, which allow you to modify existing functionality of RPC calls, and it also allows you to simply add new functionality, like in this case where we added functionality for ENS. And yeah, you also have the simplified error management and so on. So why is all of this actually important? Because it allows you to focus on what really matters for your business, which is delivering your own apps. And you don't have to fight with the library. You don't have to worry about the bottlenecks. You just have to follow the API of the library, and you should be only focusing on your business case. So, what does the future look like for EthersKT? Our main goals for 2024 are to release a first stable API version of the library. We're just finalizing the API at the moment, and we expect to release it in a stable version in around 2 weeks. So by the end of June, we're gonna have the stable release. After that, we're going to focus on Kotlin Multiplatform, and after that is done, we're going to support the R1 cryptographic curve, which I'll talk more about at the very end. So our plan for Kotlin Multiplatform is split in three main stages. The first one is to replace the existing libraries that we are using with Kotlin Multiplatform libraries. The idea here is that this will allow us to reuse as much code as possible across different source sets and to make the project much easier to maintain down the road. After that is done, the plan is to split the project into multiple targets. Initially, we're gonna split it into only two, into the common module and the JVM module. And after that, we can focus on adding support for the iOS target as well. And also, after that is done, by supporting the R1 curve, this will allow turning every mobile phone into a Web3 account. Currently, for historical reasons, the Ethereum ecosystem uses the K1 curve, which is not natively supported on mobile phones. So it's not that simple. It's not as simple as with R1 curve to use your mobile phone as a wallet. There are currently ongoing efforts in Ethereum ecosystem to support this R1 curve, and probably it's going to first be implemented in different rollups and L2 chains, but eventually this should also find its way to the Ethereum ecosystem. So yeah, this concludes my talk. We would love to get some feedback from mobile developers on this library, so we can improve it even more. We at Kriptal, we are not mobile developers. We build this for our own needs. But it would be really nice to get also some direct feedback from mobile developers. So yeah, you can scan these QR codes and you'll get to the repository for EtherSKT. And I would love to talk more if you're interested in using this library after the talk. So thank you. Any questions?
Are there any code examples how to use this library?
Yeah, we have a lot of code examples in our repository for different things, so you can have a look there if you want to know more in depth how to use it.
I have a question. You mentioned that you want to split the targets into common and JVM. What's the reasoning behind this?
Well, in JVM we can have then the JVM specific code, which are our own trading infrastructure targets. So we can make some Java specific optimizations there. But I think most of the code will be able to live in the common module.
What's some expected timeline to move everything to multi-platform?
We expect to have some examples by the end of Q3, start Q4. There's not a lot of things that need to be done to replace the libraries. But after the libraries are some libraries are replaced with the multi-platform ones, this should be pretty straightforward.
You basically mentioned that nobody from the team is a mobile developer, right?
Yeah.
So what's the background, like backend developers, Java developers?
Background of our team, or we are backend developers. We develop trading bots for our own for ourselves, and yeah, we don't work with UI.
And how hard was it for you to get into mobile SDK development and to get a better grasp into Kotlin Multiplatform? Or was the learning curve like really hard or not?
Not that difficult. I made in the past some simple mobile apps on Android, so I roughly know what needs to be, what that looks like. So right now the library targets only Android and JVM, but we see a lot of opportunity, especially now that the Kotlin Multiplatform has gone stable. We see a lot of opportunity to make this to push this library so teams can have the same code in simpler development cycle for their apps.
Cool. Yeah, because the whole story sounds quite interesting, because you're not an Android developer, you're not an iOS developer, you're on the back end and using KMP to cover platforms.
Yeah, this is not for our own internal needs at the moment. We might start developing mobile apps in the future, I don't know. But we just saw a really good opportunity with Kotlin in Kotlin Multiplatform to help teams deliver mobile apps and for different platforms in the future with the same code base.
Ooh, then a provocative question. If you would have to do it once again, from the start, would you still use Kotlin Multiplatform or something else?
For the library, or our own, or do you mean our own tech stack?
For both.
For our own tech stack, we would probably go with Rust. But it's a bit a challenge to write everything now. We still use some bits here and there for the hotpads in Rust. But yeah, for the library, if we did it in Rust, if we had our own infrastructure in Rust, we wouldn't need the library. So can't answer that.
Thanks for that.
You mentioned that the Solidity gets compiled into Kotlin.
No, it gets compiled into a JSON ABI file, which is JSON, and that contains the interface definitions of the functions, the contracts itself, and the events, and all about the contracts. And we take that JSON, and based on that, we generate Kotlin classes, which act as wrappers for Solidity code. So basically, we hide all of the complexities from encoding and decoding data and so on from the user.
You have that in-house made to do that?
Yeah. We used Kotlin Poet to generate this.
And where do you have an implementation of the cryptographic curves?
We use at the moment Bouncy Castle, a library, but
It's not multi-platform, right?
no, this is not multi-platform. This cryptographic code will be implemented for each platform specifically. Yeah.
It's hard implementations, if possible.
Yeah, I didn't see any multi-platform libraries yet for cryptographic stuff.
Libsodium.
What? Which?
Yeah, does anyone know about Libsodium?
No. Libsodium?
I
No.
don't know if it has this curve.
It has
I haven't
KMP.
used.
It's like KMP library, but yeah, I'm sure.
It's native library, so you can call it for everywhere.
Okay, I'm gonna check that out, but yeah. Even if honestly, even if in our own trading infrastructure, we used native code for cryptographic stuff because it's just much faster. So we eventually also plan to, in the library, one option is also in the library to have the native code for the cryptographic stuff, but we are not decided yet how to approach that. Any other questions? Okay. Thank you.
Thanks.